Hi, welcome to System Call session. So, in this session, we are going to talk about system calls. What is the meaning of system calls, and what is the role of system calls in our Linux operating system as well as in Linux kernel? Why the system call was required in Linux kernel, and what is the pros and cons of like implementing a new system calls, or do we really need to implement a new system calls? So these all things we are going to discuss during our session of system calls. So before jump into the definition of system call, let's first understand what is the need of system calls actually. So you remember, like in the last sessions actually we discussed about user space and kernel space. So just to reiterate the same thing, even in case if you are not aware about it. So our process address space in Linux is basically divided into two parts. The first part is user space, and another part is kernel space. So user space is the area where our most of the user space applications runs basically, or the user space library that exists in users space actually. Okay, so whenever you are performing anything in user space process, so you will be basically utilizing the resources which are available to the users address space actually, but you are not allowed to interfere with the kernel resources actually. So if you need anything to be like any help from the Linux kernel, then there should be a way of requesting the service from Linux kernel actually. For example, like all the device driver basically lie in kernel space actually. Kernel space is the area where most of the privileged programs runs. So when I say privileged programs, it means the VIP kind of program which has all the system privilege which it requires to execute actually. So it will have kernel, that is the most important part which runs in the kernel space. And with the kernel we have architecture dependent kernel code as well, because this whole operating system is basically going to be deployed on any hardware platform. It might be x86 based architecture, or it might be ARM based architecture. So on the lower layer we have hardware layer, and this hardware layer basically closely interact with Linux kernel and their device driver actually. But user space point of view, they don't have any direct access to this hardware. So if your user space application has to perform some operation on hardware, or if they want to access any hardware, then they are not allowed to use these hardware directly actually, because they have to request the device driver of that particular hardware who is maintaining that. So let's say you want to basically capture some data by using the camera. So camera is a hardware here actually. Okay, so this camera lies in the hardware layer of your system. Okay, and somewhere in the kernel you will have your camera driver, right? So this driver has access to this camera hardware actually, but there is no direct access to the application if they want to perform some operations on this camera hardware. So if any of the application, let's say if you take example of Android application, so Android application also have Linux kernel on the lowest layer, and above layers have their user space libraries as well as user space application that are written in Java, and main framework which is written in C++. But to not to complicate this, we'll just talk about simple Linux operating system architecture actually. So let's say there are some application which wants to access the camera device connected to our machine actually. Okay, so to operate this camera device they need to access this camera hardware, but as you know, camera hardware can directly accessed by the driver which is sitting in the kernel space actually. Okay, so somehow our user space application has to make a request to this camera driver that I want to use camera, or can you please do me a favor, can you please capture some frames by using the camera device which is present into the hardware layer of our system. Okay, so once so now your kernel driver basically, kernel camera driver basically will will process the request which came from user space application, and then it will start performing the capturing the camera basically, or the hardware. It will initialize the camera, then this driver will send the command to this camera driver to capture the frame actually. okay, or the camera hardware to capture the frames. Okay, so that particular period of time our kernel driver, basically camera driver, is executing on behalf of user space request. So we call that since system call context as well. We'll discuss that in detail in the coming session actually. Okay, so just to understand here, if any of the privileged task has to be performed from the user space application, so user space application are not allowed to perform those privileged tasks directly, so they need to take help of Linux kernel to perform those privileged tasks actually. So to send their request to Linux kernel and to ask Linux kernel to perform the task on behalf of them, they need some kind of interface. So to satisfy these kind of requirement, Linux kernel comes up with the concept of system calls. Okay, so system calls basically behave like a layer between your user space and the kernel space. So if you can see here on the top layer of your kernel space, so this is your kernel space actually. On the top layer of kernel space you see this system call interface. Okay, so whenever your user space application wants to uh, have some privilege uh, operation basically, so they request Linux kernel by using any of the system call or appropriate system call for the corresponding operation actually. So that system call basically will comes down to the system call interface, and then system call interface will take the control of the system call which is coming from the user space application, and it will perform the appropriate operation according to the system call invoked from the user space. So you can take example in the user space application. You are writing a C program. Let's say you are writing a C program. Okay, and in that C program you are writing printf hello. Okay, so when you run this program, right, so you are expecting some output on the console basically. So this hello should be printing on the console when you are running the program, but you know this console is actually an hardware, okay, which will be there in your hardware layer of your system actually. So you will have console here. Okay, and you want to print this message on this console actually. So as I said, your user space application, basically your C program, that doesn't have direct access to this console hardware, and you are not allowed to write directly onto this console basically. So how it is done actually, when you call this printf, so this printf is basically defined in your gnuc library or glibc, right? So gnuc libc basically internal call a system call. Let's say it calls write system call. Okay, so this write system call is defined for writing the data onto the device, which we are going to mention in this system call actually. So while writing, basically somewhere internally when you call this printf, your gnuc library will call this write system call with the required argument. So this argument can be the buffer which you want to print. Let's say it will pass a buffer. I'm not talking about exact syntax, just to give you an idea actually. So the first argument is hello, and then the length. So length is 5, and then the device actually on which it wants to write. So the it is console actually. So let's say your C program have already, sorry, your GNC library has already opened the uh, so they have done this, they have opened the console basically. So let's say they have opened dev console 0 kind of. Okay, and they are opening it with read write mode. So your printf function, which is implemented in gnuc library, so it will be doing this kind of operation. First it will open the dev console, okay, and then they will call this write function or the write system call with the required argument. So first will be the buffer, and second will be the size, and then this fd basically, which you got as a return for opening this console device basically. So you call this write system call. So this line till here basically you are in user space. Okay, and then after the user space call, the system call, right, so your switching, context switching will happen, and your system will switch to the kernel space basically. So this write system call is implemented in the kernel actually. So here you have system call interface SCI. So this is the system call interface. So system call interface will basically get the request of writing this buffer to the console. Okay, so the system call interface will finally interact with the console driver. okay, and it will print your message on the console. So this is how basically your call basically play an important role whenever you want to have some privileged kind of operation from the kernel actually. So system call is an interface basically which is defined between your user space and the kernel space. So this allow your application to request the privileged services from user space to the kernel space. Okay.